So vertical asymptotes, if you remember, that was an assignment you were supposed to do, watching the video and doing it yourself. So I hope you were able to get that done. But a vertical asymptote is after you simplify it, it's what makes the denominator 0. So simplify the equation and then set the denominator equal to 0, right? And see what makes it equal 0. So on the first one, it's already simplified. So I can say x minus 1 cannot equal 0. So I'm going to add 1. So x cannot equal 1. Okay, so that's where my vertical asymptote is at x equals 1, right? So for 2, if I factor the top factors 2, x minus 4 and x plus 3, and the bottom factors 2, 4 times x plus 2, so nothing cancels out. So what's going to make the bottom 0 is x plus 2 equals 0, so subtract 2. So x equals negative 2. There's the equation for my line. X can't equal negative 2, so the equation for the asymptote is x equals negative 2. 3 is already simplified, so negative x minus 2 equals 0. Add x. So x equals negative 2 again. And then the last one, I'm going to simplify, and I get 3 times x minus 1 over x minus 4 times x minus 1. So that goes away, and I get left with 3 over x minus 4. So x minus 4 equals 0. So my asymptote is at x equals 4. Okay, is there any questions? We okay? Wasn't too bad, right? It's just where the asymptote is where the denominator would be 0 at. So I'm just going to take that denominator after it's simplified and set it equal to 0. Okay? So nice job, everybody. Thank you. By the way, this class had the least amount of people emailing me about being gone. So thank you about that. So thanks for at least kind of listening to me. So we're going to move on to part 2, and we're going to talk about the difference between a vertical asymptote and a hole. So now we're going to talk about holes. But first, what we're going to do is you're going to take a graphing calculator, well, without a graphing calculator, sorry, and match each rational function with the correct graph, right? The function below the graph. You may want to match the ones you know first, considering exponent roles and how the function may reduce to a simpler form. So you might want to simplify them and see if you can match them. And what I did to help make this just a little easier is just call this graph A, B, C, D, E, F, G, and H, and then start calling this 1, 2, 3, 4, 5, 6, 7, and 8. That way in chat it's a lot easier to match, right? So, I mean, if you have the packet, you can just write the equation underneath the graph, but it's a little harder for you guys to put your answers for me into the chat without having something to match it with. So that will make it a little bit easier, okay? So I'm going to go ahead and pause that, give you guys a little bit of time. Simplify your equations. That will help you decide which graph goes with which equation. You know a bunch of these. So I would just start with my equations, and this is how I do it. I start with my equations. If I don't know what that equation of that graph looks like, skip it, go to the next one. Does that make sense? So like the first two, I'd probably skip 1 and 2 right off, because 3 I can simplify really easily, right? And 3 simplifies down to y equals x. And I know what the graph y equals x looks like, right? So I can find that graph really easily. So that's what I would do, and do the ones that I know really easily what the answer is, and do it that way. Does that make sense? Okay. So let's go ahead and start with number 3, since I've got that simplified down. So y equals x is c. So this is y equals x squared over x, or x, y equals x, right? So number 4, first of all, I know I can simplify this to 1, okay? Also, x cannot equal 2, right? Because I can't have a 2 in my denominator to make it 0, right? So it's going to be x equals 1. Well, I have 2 graphs at that choice. I have either B, I can either choose B, or I could choose G, right? That's the graph of y equals 1. The difference here is this little note that says x cannot equal 2. Here, x can equal 2. Here, x cannot equal 2. So it's going to be G. So this one is y equals x minus 2 over x minus 2, which equals 1. Okay. 5 is going to be, I can simplify 5 to x squared, and I know that x squared is a U shape, right? So x squared is a U shape. So it's either D or H, and since it's not adding or subtracting anything, it's D because I'm not shifting it anywhere. So y equals x cubed over x, which equals x squared, right? Let's see, 6, that is a 6, right? Yeah. So this simplifies to x minus 2. That's a straight line again that starts at, that has a y-intercept at -2 and has a slope of 1, right? So that this is E. So this would be y equals x minus 2 squared over x minus 2, which equals x minus 2, right? Okay. And then, where are we at? This equals 1. So we already know that this is we only had one choice on that. This is where x cannot equal 0. So this is y equals x over x, which equals 1. Okay. And then 8 is going to be x minus 2 squared. So again, I've got a square, so it's a parabola. So it's got to be my other parabola I have left. Shifted right to the right 2. That's what minus 2 means. I'm going to the right 2. So this is y equals x minus 2 cubed divided by x minus 2, which is x minus 2 squared. So now I only have 2 choices left. I have the x 1 over x minus 2 and the 1 over x. Well, all the rest of them that had the x minus 2's in them shifted everything. If you look at the graphs, sorry. If I look at the graph, if I look at the parabola, look, one started at 0, one shifted. The one that had the minus 2 shifted to the right 2. If I look at the line, y equals x and y equals x minus 2, again, the one with the minus 2 shifted to the right 2. So I'm just going to assume that it follows the pattern, right? It's going to shift to the right 2. So the x minus 1 is going to shift to the right 2. So I'm assuming the x minus 2 is f, and just the x by itself is a, which is right, by the way. But they follow the same rule. So if it has a minus 2 in it, it's going to shift to the right 2. Does that make sense? So that still follows the same rules. So this is y equals 1 over x, and this is y equals 1 over x minus 2. Now, I do want us to kind of notice, other than those two, every single other one, we had to cancel something out, right? And if you notice, each of the graphs had this like little hole in the graph, right? Right there, right here, here, and here. And that spot happens to be where I canceled out what happened to get canceled out, right? So here on graph B, I canceled out, let me write it here. X could not equal 0, because that would make my denominator 0. Here, x could not equal 0. And there's a hole at x equals 0 and a hole at x equals 0. X could not equal 0. Here, x could not equal 2. And now there's a hole at x equals 2. Here, x could not equal 2. And now there's a hole at x equals 2. X could not equal 2. So when I canceled something out, all of a sudden there's a hole on my graph. Okay? This kind of makes sense? So basically that's what a hole is. find it now. Oh, actually, they wanted you to describe what functions have asymptotes and which functions have holes. We just kind of talked about that, so we're going to skip that question a little bit. And we're going to talk about how to find holes. Holes appear when there's the same factor in both the numerator and the denominator. So all the rest of them, we canceled stuff out. You can see we canceled the x minus 2 and x minus 2 out in my example. What factors did we cross out when simplifying? Plug that number back into the simplified equation. So how I find out where that hole is actually located at? I'm so sorry. So my example is I had an x minus 2 and an x minus 2, right, in the numerator and the denominator. That meant I had x equals 2. So I take that x equals 2, and I take that x and I plug it back in to my simplified equation, right? The equation that's left over, which was the x plus 1. And then I will get the location, my y value. So if I plug that back into here, I'm going to get 2 plus 1, which equals 3. And if you look at the hole right here on my graph, right here, let me not do that. Here, if you look at that point is 3. I'm sorry, that is not 3. Wow. Now I'm doing this. I couldn't spell anything last period, and now I can't write anything right this period. 2, 3, right? X equals 2, y equals 3. So how I find the location of the hole, the x is what's canceled out, right? I solve for that x value. I plug it back into the simplified equation, and that gives me my y value. And that tells me where on my graph my hole is. And when I'm sketching my graphs, which we're going to start doing pretty soon, right? After we go over each little piece, I actually put a hole on my graph. I draw a hole just like it looks like here. I'm just going to draw a circle on my graph, and then the line will go up to it and past it, just like it looks like on this graph. So that's how the holes work here. So our next little section says, what does our next section say? Determine whether the graph of the rational function has a vertical asymptote, a hole, both or neither. Then find the vertical asymptotes and or holes. So I need to find both, okay? So how do I know if it has a hole? Simplify the equation, right? I always start with simplifying my equation. Okay, so I'm going to simplify my equation. If I can simplify my equation and cancel something out, it has a hole right there. Okay? If I can't simplify the equation and nothing crosses out, no holes. Okay? And of course, if there's something in the denominator, then I'm going to have a zero, an asymptote there. Okay, that's all. It's that easy. So if I look at question number 1, let's get in here. Question number 1 is already simplified. There's nothing I can factor out, right? So there's going to be no holes. So I'm going to just write that here. No holes. Okay? Or let me do it this way so I can be consistent the whole way through. So I'm going to say holes, none. And then vertical asymptotes. And instead of spelling it out, I'm just going to put VA, okay, because we're going to be writing it a lot. And my vertical asymptotes are what makes my denominator 0. So I'm going to say x squared plus 4 equals 0. Subtract 4. X squared equals negative 4. Square root. X is going to equal plus or minus 2i. So my vertical asymptotes are at x equals plus or minus 2i. Done. Any questions? Do you guys have any questions at home? Okay, let's go ahead and go to the next one. And we're going to do the same thing. So I'm going to write my 2 words here, holes and vertical asymptotes. Okay, so I can simplify my equation, and my new equation becomes 1 over x. Okay, so I know I'm going to have a hole at negative 2, right? So why is it negative 2? Because if I have x plus 2, and I set that equal to 0, I'm going to subtract 2, and x becomes negative 2. And then I plug that back into my simplified equation. Okay, so I'm going to take that -2, wherever there's an x, I'm going to put it into, so I could write it this way. I'm going to find r of -2, right? So that's 1 over -2. So that's -1/2. So there's where my whole is going to be. -2, -1/2. Okay? And then I need to find my vertical asymptote. And my vertical asymptote will come from my simplified equation. So I'm going to look at my simplified equation, which is this one. So I'm going to look at my simplified equation, which is this equation, and find out that I'm going to have a vertical asymptote at x equals 0, right? So I don't have to solve for anything because it's just an x by itself. What makes x 0? Well, 0 does. Is there any questions so far? Are we okay? Yeah? Okay. We're going to do the same thing on the next problem. Ooh, okay. So holes and vertical asymptote. So I guess I'm going to have to factor this. So I should get, what am I going to get? X plus 2 over x minus 5 and x plus 3. Yeah. So there are no holes, none, because I can't simplify it. It's as simplified as it's going to get, right? And then I should have vertical asymptotes at whatever's going to make my denominator 0. So that's x minus 5 equals 0 and x plus 3 equals 0. So x equals positive 5 and x equals -3. How did I get that? I added, right? Any questions? Down here, you okay with that? Okay. All right, so you guys have 6 problems to do that with. And I'll kind of leave that up there so you can kind of see the notes. I know that wasn't probably enough time to do all 6 problems, but we're going to go ahead and start. So, holes. There are none because it's already simplified. So, none. And then my vertical asymptote, x squared equals negative. Oh, so sorry. Let's try that again. X squared minus 4 equals 0. Then I'm going to add 4. So x squared equals 4. Square root. X equals plus or minus 2. So I've got one at x equals 2 and one at x equals -2. Okay. And then for B, holes. It's already simplified, so I've got no holes. H-O-L-E, oh my Lanta. Okay. Let's just try it one more time. H-O-L-E-S. Okay, vertical asymptote. Why did I spell holes twice? It's definitely one of those days. None. Okay, there we go. My vertical asymptote is where x, my denominator equals 0. So x is going to equal -5. And then simplify. So I've got x over x minus 5 and x plus 3. So holes would be none. And my vertical asymptote, I should have one at x equals 5 and one at x equals -3. Questions? Does anybody not know where I'm getting 5 and -3 at? Okay, great. Okay, and then we're going to D, where it looks like I'm going to factor 4 over x plus 2 times x plus 2. So holes would be none. And my vertical asymptotes would be x equals negative 2. And then simplify this, becomes 1 over x plus 2. So in this case, there's still no holes. I did simplify it, but I didn't cancel out any x's. So there's still no hole. And my vertical asymptote would be at x equals negative 2. Whatever's going to make my denominator 0, it's still negative 2. So there's that. Any questions so far? Are we okay? It's kind of making sense. It's not too bad so far. Okay, awesome. And then the last one, right, I'm going to simplify it, and I get 1 over 7. So I have a hole at 0, and then 1/7. I mean, it's kind of hard. There's nothing to plug x into, so that's just 1/7, right? So it's 0, 1/7. And then I have a vertical asymptote, none. I don't have a none. I don't have any vertical asymptotes. There are none, okay? Because it's only, there's nothing left in the denominator, so there's no vertical asymptotes. Okay, is there any questions? Are we okay with this so far? My Zoomers, are you guys okay? Okay, awesome. All right, so let's see, what does it say? So we're still doing the same thing. So we got 6 more problems, only these ones are a little more difficult. So I'll give you guys a little, do these. I'm gonna go ahead and start anyways. X minus 2. X minus 2. Okay. If I do something that you guys don't understand how I got it, please let me know so I can go over it. So the whole for the first one is at 2, negative 3/2. And the vertical asymptote would be x equals 0. How do I want to write this? Oh, it's not negative x squared. Oh, it's a plus 2. That's what I did wrong. Vertical asymptote. Add x. X equals 2. Holes, none. Vertical asymptote. X equals negative 2. Plus 2. Okay, that's right. Okay. Okay, I'm going to factor down here this time. Negative 2x poles would be at 3. So that's going to be -2 times 3 over 3 minus 4, -1, 3, 6. Vertical asymptote is going to be x equals 4. Let's see this. If I take a -4x out, I'm going to get x squared minus plus x minus 6. Okay. So this factors to x plus 4, x minus 2. And I get -4x times x plus 3 and x minus 2. I think that looks like it's right. So my whole, it's going to be ugly. It's going to be at 2. And then I get 2 plus 4 over -4 times 2 times 2 plus 3, which is going to equal 6 over -8 times 5, -40. So 3 -20s, -3 over 20ths. Wow, okay. And my vertical asymptotes are x equals 0 and x equals -3. That was an ugly one. And then f, I think I can factor a 2 out, and I'm going to get x squared plus x minus 2. So it factors to 2 times x plus 2x minus 1 all over x minus 3, x minus 1. So my whole is going to be at 1. It's 2 times 1 plus 2 over 1 minus 3, which should be 6 over -2, which is -3. Okay, and then my vertical asymptotes should be, what are my vertical asymptotes, or of asymptote? X equals 3. Is that right? Beautiful. Okay, there you guys go. Questions? No, is it terribly bad? It's not too bad, right? The factoring's not too bad. And in fact, it doesn't get really any harder than this on Delta Math. Okay, and I think you have 16 problems. So I think, so if you want to go ahead and get those done, you have about 20 minutes, 25 minutes. You should be able to get your assignment done. And I'm going to get your grades caught up. So I hope that some of you guys got your